So in the do now, it says Dan is standing 6 feet from a lamppost that is 8 feet high. So right now they're talking about the lamppost. They're talking about Dan, but they're also connecting the lamppost and Dan. How are they connecting the lamppost and Dan? So they're talking about the lamppost. They're talking about Dan, but then they're connecting the lamppost and Dan. How do I know that they're connecting the lamppost and Dan? Kaylee? Good, because he's saying Dan is 6 feet from the lamppost. They didn't say there's a lamppost and somewhere down the street there's Dan. If they said there's a lamppost and somewhere down the street there's Dan, would you connect Dan and the lamppost? No, they're connecting Dan and the lamppost by saying they are 6 feet apart. That's the difference. So we have our lamppost. The lamppost is 8 feet high. And then it's saying 6 feet from the lamppost. So here's 6 feet. We have Dan. So we have our lamppost here. And then you have Dan here. And it says Dan is 5 feet tall. How long is his shadow? Remember, it's the light from the lamppost that's creating Dan's shadow. So what are we going to do? We're going to create this segment here and call it X. That's his shadow. We're now going to connect to create a triangle. Now we've created 2 triangles. We've created the big lamppost triangle, and then we've created the little Dan triangle. So I'm going to redraw these 2 triangles so they're not connected. So we have the lamppost triangle. The height of the lamppost triangle is 8. The base of this lamppost triangle is not 6. It ends up being 6 plus X. Then you have the little Dan triangle. The little Dan triangle, its height is 5 and its base is X. These 2 triangles are similar, so because they're similar, we're going to be allowed to make a proportion. So I'm going to say 8 over 5 is equal to 6 plus X over X. We're going to cross multiply. We're going to get 8X is equal to 5 times the sum of 6 and X. Distribute in that 5. We get 8X is equal to 30 plus 5X. Subtract the 5X. Subtract the 5X. And we get 3X is equal to 30, so X will equal 10. So that means the shadow is 10 feet long. Can I move on to the next one? Okay, so for number 2, I asked for you to solve for X, and I said, hint, redraw the 2 triangles. Now, these triangles are absolutely similar. Why are these triangles similar? Well, I gave you parallel lines, and do you all see that upside down F there? Because of the parallel lines, these 2 angles are congruent, and there's an F on the other side too. These 2 angles are congruent. So the small triangle and the big triangle are absolutely similar. These triangles are absolutely similar. So I said redraw the triangles. When I redraw the smaller triangle, I have a side of 8 and a bottom side, a side of 6 and a bottom side of 8. But then there's the big triangle. What's the side length of the left side length of the big triangle? It is not 3. It is 6 plus 3, which is 9. And the bottom side is X. Because these 2 triangles are similar, can we set up a proportion? Absolutely. We know, let's see, this angle is congruent to this angle, and this angle is congruent to this angle. All right, so I'm going to say 6 over 9 equals 8 over x. Before I cross multiply, I'm going to simplify down this first fraction. So I'm going to divide top and bottom by 3. So we're going to have 2 over 3 equals 8 over x. Cross multiply, we're going to get 2x equals 24, and x will equal 12. All right, some things I saw on the quiz, not very often, but some things I saw that were big no-nos. Let's say I have, I don't know, 5 over 4 equals 8 over x. Guys, are you allowed to cross simplify through an equal sign? Can you do this? No, you cannot cross simplify. You cross multiply in a proportion. You cannot cross simplify. What operation are you allowed to cross simplify between? What has to be between the two fractions? What operation? Multiplication. There needs to be a multiplication sign there. If it's an equal sign, you cannot cross simplify. That is a big, huge algebraic no-no. Can't do that. Right? All right, let's look at number 1. We want to solve for x. So in order to solve for x, guess what I'm going to tell you to do? Yeah, exactly. I'm going to ask you to redraw the triangle. So the small triangle, we have x and 6. The large triangle, the bottom side is 18. What's the left side length of the big triangle? 4 plus x. So now we set up our proportion. I can have x over 4 plus x equals 6 over 18. Before I cross multiply, guess what I'm going to tell you to do? Simplify. I'm going to divide this top and bottom by 6. So now I have x over 4 plus x equals 1 over 3. Now we cross multiply. And I'll bring it up here. I'm going to get 3x is equal to 4 plus x. I'm going to subtract that x. 2x is equal to 4, and x is equal to 2. Oops. All right, let's look at number 2. Again, these two triangles are similar, so I'm going to redraw them. I have a 9 and an x plus 2. Actually, you guys do this one. You all do this one. Are we ready? All right, so the other triangle, the bigger triangle, the side length is not 9, it's not 3, it is 9 plus 3, which is 12, and the bottom side is 3x minus 4. So now when we set up our proportion, we're going to have 9 over 12 is equal to x plus 2 over 3x minus 4. Okay, so before I cross multiply, I'm going to simplify down the 9 over 12. I'm going to divide top and bottom by 3. And when I do that, I'm going to get 3 over 4 equals x plus 2 over 3x minus 4. Now we can cross multiply. And I'm going to, let's bring it up here. I'm going to get 3 times the quantity of 3x minus 4 equals 4 times the quantity of x plus 2. Distribute in. We get 9x minus 12 is equal to, distribute in, 4x plus 8. I'm going to subtract 4x on both sides. We get 5x minus 12 equals 8. Add that 12 over, we get 5x equals 20, so x will equal 4. Solve for x, we solved for x. All right, new theorem, the side splitter theorem. The side splitter theorem tells us if a line is parallel to one side of a triangle and intersects the other two sides, it divides those two sides proportionally. All right, this is huge, the side splitter theorem. What does this side splitter tell us? So this side splitter tells us if I have a segment in a triangle that's parallel to one of the sides of a triangle. So in this diagram, do I have that? Do I have a line in the triangle that's parallel to one of the sides? Yeah, it's going to split the sides proportionally. What does that mean? I can then say A over B equals C over D. Right, this only works for sides, not the bottom side. Only works for left/right sides, never the bottom. It only works for the left/right sides, never the bottom. And you'll see what I mean when we get to a problem like that. Okay, so example 1, it says solve for x. Does side splitter apply here? Does side splitter apply here? Absolutely, because what happens? We have a line in the middle of the triangle that's parallel to one of the sides, and that means it splits the sides proportionally. Are we trying to find one of those sides? Absolutely. So here we're going to say 2 over 8 equals x over 12. This is side splitter. Before I cross multiply, I'm going to simplify down. I have 1 over 4 equals x over 12. Now we cross multiply. So I'm going to have 4x equals 12, so x will equal 3. All right, number 2. It tells us that AC is 6, that DE is 8. Does DE look like it's 8? No, is that okay? Yeah, because nothing's drawn to scale. And then it says EB is 3 times as long as AD. Right? Since EB is 3 times as long as AD, EB is smaller. I'm sorry, AD is smaller. So I'm going to go to AD and I'm going to call it X. If AD is X and EB is 3 times as long as that, how am I going to represent EB? 3X, you got it. Can I use side splitter here? Yeah, I have a line in the middle of the triangle that's parallel to the base, and the unknowns are on the side. If the unknown was on the bottom side, I can't use side splitter. So I'm going to say it one more time because this is super important, right? If we have a segment in the middle of the triangle that's parallel to one of the sides, and the unknowns are on the left or right side or both of the triangle, we are allowed to use side splitter. If the unknown, if the variable or whatever we're trying to solve for is on the bottom side of the triangle, sort of the base, where it's not really the base, but the bottom side, we are not allowed to use side splitter. But the unknown is on the left and right side, we can absolutely use side splitter. So what am I going to do? I'm going to say X over 6 is equal to 8 over 3X. Side splitter. Now, when we cross multiply, bring your algebra skills back into gear here. 3x times x. What is that? 3x times x. You got it. It is 3x squared. Then we have 6 times 8 is 48. We're going to divide by 3 on both sides. Then we get x squared is equal to 16. To undo a square, what do we take? The square root. We take the square root. Technically, isn't x plus or minus 4? Right? Positive 4, negative 4. But can a side length ever be negative? No, side length can't ever be like negatives. I'll write that. Side length can't be negative. So reject the negative. So we just get x is equal to 4. So now that we know that x is equal to 4, we can plug in AD is 4. How long is EB going to be? 12. You got it. So then it's asking me to find DB. Well, is DB 12? No. What's DB? 8 plus 12, which is 20. All right, let's put a little star on number 3, and we're going to write side splitter can never be used on the bottom side. You must create similar triangles when solving for the bottom side. Okay, so I'll give you a second to write that and then we'll chat a bit. Okay, so look at this. Can we use side splitter to find x? Absolutely. Can I use side splitter to find y? No. So we're going to treat this like 2 separate problems. Let's first find x. Okay, so if we're going to find x, what we're going to do is, let's actually write it out. So I'm going to do side splitter to find x. There we go. We're going to use side splitter to find x. So we're going to say 6 over 3 equals 8 over x. Before I cross multiply, I'm going to simplify down 6 over 3 down to 2 over 1. Cross multiply, we get 2x equals 8, so x will equal 4. All right, now we need to find y. We need similar triangles to solve for y. Can I tell you what not to do? That so many students, if they're going to mess up, this is how they mess up. So the students that mess up, they end up doing 6 over 3 equals 10 over y. No. Nope. Okay, why no? Why no? Lexi? Good. Isn't 6 over 3 the side splitter? We can't use side splitter to find the base, right? What do we have to do to find the bottom side of a triangle? We must create similar triangles. We can't use part side splitter, part bottom. Can't do it. We have to use similar triangles. So what do I mean when I say we have to use similar triangles? Well, I'm going to draw the smaller triangle. And we get 6, 8, 10. And then we're going to have the larger triangle. Now, didn't we just figure out that x was 4? Since x was 4, we now use the big side. So this side is 12, this side is 9, and the bottom is y. Can we now create a proportion from these similar triangles? Absolutely. So what is our proportion going to be? I guess I'll do 6 over 9 equals 10 over y. Right? Before I cross multiply, I'm going to simplify 6 over 9 down. So I'm going to get 2/3 equals 10 over y. Cross multiply, we get 2y equals 30, so y is equal to 15. I want you to go ahead now, and I want you to find x, and I want you to find y. Okay, question for you. Can we use side splitter to find x? Yes or no? Yes. Can we use side splitter to find y? No. Right? So side splitter for x, not side splitter for y. Are we ready? All right, what should we have done here? So we should have done, for side splitter, so side splitter for X, similar triangles for Y. So we're going to have 8 over X plus 2 equals 6 over X plus 1. Also, just an FYI, you could have done 8 over 6 equals X plus 2 over X plus 1. That would have also worked, just so you know. Cross multiply, we get 8 times the quantity of X plus 1 equals 6 times the quantity of X plus 2. Distribute in, we get 8X plus 8 equals 6X plus 12. Subtract, we get 2X equals 4, so X will equal 2. So now we plug in that 2 to help us solve for Y. So this side is 4 and this side is 3. Now for Y, we have to create our similar triangles. So our small triangle is 8, 6, 12. Our larger triangle is 12, 9, and Y. 12, 9, Y. So now again, we create our proportion out of the similar triangles. So I'm going to say 8 over 12 equals 12 over Y. Simplify the 8 over 12 down to 2/3 equals 12 over Y. Cross multiply, we get 2Y equals 36, so Y will equal 18. Now we want to find the perimeter of the big triangle, ABC. Well, now we know all the sides. So the perimeter of triangle ABC is going to be 12 plus 18 plus 9. 12 plus 18 is 30. 30 plus 9 is 39. All right. Theorem. If 3 or more parallel lines, I'll take it. If 3 or more parallel lines are intersected by 2 transversals, the parallel lines divide the transversals proportionally. This is like side splitter on steroids, okay? It's just taken up a notch. Okay, so now we just have more sides to split. That's all it's saying. So if you look at this right here, we are allowed to set up the proportion A over B equals C over D. You can do A over C equals B over D also. So let's look at some examples. Number 1, we want to solve for X. I am absolutely allowed to use this new side splitter theorem on steroids. So this is going to be 3 over 4 equals 6 over X. Cross multiply. 3x equals 24, so X will equal 8. Okay, so now I'm going to complicate things very slightly. It's not by much. So now I'm telling you that line A is parallel to line B, which is parallel to line C, which is parallel to line D. So not only have I given you parallel lines, I've given you more parallel lines. Now I've given extra lines. We're allowed to use, yes, Dimitri. You're welcome. You good? Okay, so now I've given you more parallel lines. All right, we can still use the side splitter on steroid idea, but we are given the sides on the left side, 5, 2, and 8, the side lengths on the left side. But on the right side, the only thing we're told is that KP is 24. Well, which side does KP correspond to, do you think? F2 FJ. Now, do I have a length for FJ? No, but can I find a length of FJ? Yeah, we're going to add. 8 plus 2 is 10, plus 5 is 15. So my starting ratio is going to be FJ to KP. And FJ to KP is 15 to 24. Can I simplify this down? Absolutely. Divide by 3, we get 5 to 8. So my base ratio will be 5 to 8. I'm going to call KMX, I'm going to call MOY, and OPW. So now I'm going to say 5 to 8. Well, I'll do it with letters first so you know what I'm setting up. So I'm going to say FJ to KP is equal to FG to KM. So this is 5 over 8 is equal to 5 over X. What does X have to be? What does X have to be here? 8, right? For those two ratios to be equal, X has to be 8. If you didn't realize that, you just cross multiply, you get 5X equals 40, so X is equal to 8. So KM is 8. All right, now we're going to do the same thing, but now we're going to find MO. So again, we're going to say FJ is to KP as GH is to MO. So again, we're using 5 over 8 is equal to now 2 over Y. Cross multiply, we get 5Y is equal to 16. Y is 16 over 5. I would leave it just like that, 16 over 5. All right, now we need to find OP. We're doing the same thing. I'm going to say FJ is to KP as HJ is to OP. So 5 over 8 is equal to 8 over W. Cross multiply, we get 5W equals 64. W is equal to 64 over 5. I would leave it just like that, 64 over 5. When's the only time I think you should change it to like a decimal? No, not on the review sheet. Is that what you said on the review sheet? No? Oh, well, dilation because we're plotting. That's true. When else, if it weren't a dilation? If I'm asking you to add, right, it's sometimes easier to add decimals than it is to add improper fractions with different denominators or the same denominator. All right, so let's do this next one, which is also our last one. All right, I'm telling you that AE is parallel to BF, which is parallel to CG, which is parallel to DH. I'm also telling you A to D is 500. And on the other side, I'm telling you that EF is 100, that FG is 140, and GH is 160. Now, I'm asking you to find A to C. That's this one. So I'm calling A to CX. Who do you think A to C corresponds to? Which segment on the other side? Which side does AC correspond to? Lex? EG. So how long is EG? Isn't that 240? So we're definitely going to have X over 240. Are we all okay with that? But now the only side length I have on that AD side is the full AD. And that full AD is 500, which is fine. But which side does AD correspond to on the bottom? Amanda? EH. I don't have a length for EH, but can I find a length for EH? Absolutely. So we have 140 plus 160 is 300 plus another 100 is 400. So we have 500 to 400 equals x to 240. Can I simplify that 500 to 400? Yeah, I'm going to cancel those zeros. So I'm going to have x over 240 is equal to 5 over 4. We cross multiply, we get 4x is equal to 5 times 240. Now you can multiply 5 and 240, but there is a little trick. If I leave it as multiplication, I can just divide the 240 and 4, which is 60, and then that's a little bit easier to do in my head, right? 5 times 60, which is 300. All right, that's the end of this lesson.